Hello student, welcome to today's session. So today we will be discussing one important question based on the decarboxylation. This question is being sent as in doubt by somebody. So I find this question very interesting one. The starting material is being strongly heated and you have to tell about which of the following is incorrectly written about the this particular sequence of reaction. So here to begin with, I could show you that in this particular starting material, you could see few important features which you have to keep it in mind. If you don't know, you are not able to address the question. Now, one is that if I would mark this carbon as alpha because it is directly attached to the function group COH, and this would be said as beta. So here from this angle, I could see that this molecule is having this feature which we used to say it as beta keto acid. This is beta keto acid. One angle you have to keep this in mind, beta keto acid. Similarly, the same feature I can see here also. This is also the beta keto part. So on the left side of this particular starting material, you have a beta keto acid. Along with that, on to the right side, you could see this 1, 3, 4, the carbons which I have marked it. So these COH groups are at 1 and 4th position to each other. So if you talk of this one or you talk of this one, 1, 2, 3, 4. So this is having also along with 1,4 dioic acid type of a thing. Now that thing, considering all these features into mind, we have to address this question. To do that, let me do it in detail. First, let me explain those who are new to this topic. So, decarboxylation is a process in which a starting material happens to lose a molecule of carbon dioxide. So, when we speak of D means removal, carboxylation means removal of carbon dioxide. Similarly, D means removal, decarbonylation. Decarbonylation means removal of carbon monoxide gas. And similarly, if you talk of dehydration, dehydration means removal of water molecule. To exemplify what I just have said to you, let me take an example here which would strengthen you what I'm trying to say it here. Now, if you have a molecule of oxalic acid, you might have read it earlier, oxalic acid is being strongly heated. When oxalic acid is being strongly heated, what you are going to get here is this goes out as water, this dot and cross, and this H positive goes out. So here you lost this water molecule. So in a way, I will say this particular reaction involved a topic of dehydration. Along with that, if you will bring these electrons to this side, and this side this way, so what you are able to see here is there is a formation of carbon dioxide. So carbon dioxide is also being generated here. Along with that, what you are also able to see a molecule formation of carbon monoxide. So in a way, this particular reaction has involved decarboxylation, decarbonylation, as well as dehydration, decarboxylation, as well as decarbonylation. So this is very important. Now the point is that, as I was saying, that you always have to remember any starting material is having any of these four features. So this could be a very important question. In and around this you would get in upcoming JEE mains, advanced or NEET examination. I'm sure about it. So if you have a compound is having a beta keto acid, 1,3-dioic acid, alpha nitro acid, or beta gamma unsaturated acid, if it's being strongly heated, it will lead to decarboxylation. This thing you always have to remember. Now why is it so? Let me explain it in speedy way. So if I just would write this as alpha and this as beta, because why I'm saying this as alpha carbon, because the COH is the principal function group here. So beta keto acid. So if you do not want to go into the mechanistic viewpoint, we simply would write it like this. This goes here and these two electrons come here. Since this has lost one H positive, this dot and cross went to that side, making a carbon dioxide. Along with it, what you are able to get a ketone with one carbon less. So that is why it is called as decarboxylation. Why it happened it this way is simply because of the fact that if you just would write it as alpha beta, here you could see there is a intra H bonding formation possible, and this is delta positive, this is delta negative, so this is delta negative. So this delta negatives would like to snatch this H positive out towards itself, resulting in the formation of carbon dioxide. How does it happen? So this bond goes here, wow, this goes here, and this goes here. So as a consequence, this is what you also refer to as a type of chelation. What is chelation? Where 5 or 6 membered ring is formed. In this particular case, 6 membered ring is being generated, and that actually is the driving force for this decarboxylation. The driving force is the formation of this of a 6 membered ring which has been created. So what exactly do you get here is you would get this oxygen would take this H positive towards itself, and here you would get CH2, and there is a loss of carbon dioxide. So basically this is enol. This you have generated enol. If you will bring this electrons here, this here, so this H positive would come here, and this is the tautomerism, and you would get a tautomer, which is the enolic form of it. Is it okay? So this is what you always have to remember. Similarly, if you have 1,3-dioic acid, so if I would mark it as this as 1, this is 2, this is 3, so this is 1,3-dioic acid. So 1,3-dioic acid also do contain that feature. If you would strongly heat it, what would you get here is again a sort of 6 membered ring which is being generated, and it is almost the same way which we have done in the previous case. So here you also would get this would come out as carbon dioxide, and you end up getting a OH here, and this again would have the feature of enol. So this bond goes here, this goes here. Ultimately, you happen to get a carboxylic acid with one carbon less than the starting one, because one carbon has gone out as carbon dioxide. Similarly, if you go for alpha nitro acid, same feature. This is the alpha carbon. Alpha carbon is the one which is attached to the carboxylic end, and nitro part is also there at the alpha position. So this is delta negative, this is delta positive, same feature. So now you can address it very easily. So the carbon dioxide went out. This is the carbon dioxide which I am referring to. This carbon dioxide went out, and you would get a compound of this type. And this is what you call this also as a tautomeric form. So this bond goes here, this goes here. So you get alpha nitro alkane or alpha nitromethane. So this also, if you ever have done, this is called as nitro SC tautomerism. If you ever read about it, or if you have not, just see into one of the DCD series which I made last year on this particular topic, nitro SC tautomerism. And similarly, beta gamma unsaturated acid, this is alpha, this is beta, this is gamma. If you have beta gamma unsaturated acid, same type of feature can happen in this case as well. So here also you would get this becomes CH3, and along with it you are going to get a loss of carbon dioxide molecule in this particular case as well. So I hope you have gone through the four entities about it, that there are four such features which you always have to keep in mind. These are the four beta keto acid, 1,3-dioic acid, alpha nitro acid, and beta gamma unsaturated acid. One more thing I would also like to share it with you. There is a very important topic of heating on dioic acid. So what are dioic acid? So this is a small way to remember is just speak it with me like Ohm's gap, Ohm's gap, Ohm's gap. So Ohm's gap is oxalic acid 1,2-dioic acid. This is malonic acid 1,3-dioic acid, and this is 1,4, 1,5, 1,6, and 1,7. All of these are dioic acid. So we do see that when these dioic acids are heated, you end up getting different products, and this is very important. So oxalic, malonic, succinic, glutaric, adipic, and palmic acid, pamelic acid, sorry. And this OMS, I have taken the first alphabet of all these acids, and as a result it is going to set as Ohm's gap. So what happens in the first case of the case of oxalic acid? If we have just few minutes back we have already done, if you heat it, you would get a molecule of water out. You also would see a formation of carbon dioxide and carbon monoxide. So decarbonylation, de carboxylation, and dehydration, all the three things happen in the case of oxalic acid. 1,3-dioic acid is for the malonic acid, which again we just few minutes back we have done. There is a loss of carbon dioxide only along with the formation of acetic acid, where we talked about a chelation or six-membered ring has been formed. Now coming on to the case of succinic acid, this is 1,4-dioic acid and 1,5-dioic acid. These are the two cases where when you heat them strongly, you would only see a formation of, you would only see a loss of water molecules. So here you would able to get the dehydration only. So what basically do you get on dehydration? Here you would get a species which we call it as succinic acid, and here you would be saying succinic anhydride. This is called as succinic anhydride. You would get the formation of anhydride, and here in this case also you would get to see the formation of glutaric anhydride. So succinic and glutaric happens to undergo dehydration. Coming on to the 1,6 and 1,7, 1,6 and 1,7, one is adipic acid, another is pamelic acid. So in this particular case, this is very, very important to remember with. So if you have adipic acid heated strongly, you would see a loss of water molecule, as well as you would see a loss of carbon dioxide. Mechanism for this we will discuss some other day. So you would get a cyclic ketone with one carbon less, and here also you would lose water molecule along with carbon dioxide, and you would just create a cyclic ketone. So this is very, very important, that here you would see decarboxylation and dehydration in 1,6,1,7. So I would just write it here. So here you have a loss of water, loss of carbon monoxide, loss of carbon dioxide. Here you would see loss of carbon dioxide. In these two you would see loss of water. In these two you would see loss of water and loss of carbon dioxide. I'm sure about it, something in and around this particular feature would come in the paper. Now coming on to our question. So here what you are able to see here is this is alpha, this is beta, this is alpha, this is beta. If I would strongly heat it, this carbon dioxide would go out, this carbon dioxide also would go out. Along with, so two molecules of carbon dioxide surely would surely will be lost in this particular case. Now coming on to this, this is 1,4, 1, 2, 3, 4. Now if I would take these 1,4, so how does this water would go out? So OH from here, H from here. So this is a cyclic anhydride being formed here, and OH from here, H from here, cyclic anhydride is being formed here. So what basically do I get here is something like this. So you would get this entity along with, if I just would create a space here, I shall be getting something like this. So here you would get C double bond something. This anhydride is being generated, and there is a double bond also in the benzene part, and along with it you would get this feature also. So you are going to get anhydride also. So what you have lost is you have lost 2 moles of water and 2 moles of carbon dioxide to get with the final product. So what I can show you here is that what exactly I have got here is I got a species of this type. So this is what I have received, anhydride. From here also I have received a anhydride, and here I just have left with the keto part. So this is what I just have got. Now this is what is my X. This is X. I can show you here. This is my X. This is the X what I got it. Now if I just would do one more thing, because they are saying that it is going to the Y. And what is Y? I just would make a tautomeric form of it, because this is alpha carbon which can undergo tautomerism. This also is a alpha one. Now what I does show here is if this H goes here and this electrons would come here and this goes here. And similarly, if I do the tautomerism, what I do get here is here I would generate a OH, here also I would generate a OH. Along with there is a formation of double bonds. Now perfect, beautiful it is, because it is now going to get the enol form. So this is both X and Y can be said as tautomers. So this is the enol form. And as a matter of fact, during this enolization, generally we say keto form is more stable than enol. But if enol would engage a special property or special feature which bring in some stability into it, I could see here that this enolic form resulted in the formation of aromaticity. So this aromaticity would allow X to go to the Y very aggressively, very rapidly. It would turn to the Y. So in that sense, I will be saying Y is more stable. This is more stable and this is less stable in this particular case because the enol got stabilized because of attainment of aromaticity. Now, almost we have done the question. Let us see what the options they have given to us. The first option they have said Y is having phenolic and anhydride group. So this in a way is a correct statement. This Y is containing all that features which we have just shown here is something like this. Here you have which and just to save the time, let me do it speedily. So you have a anhydride also along with it. Anhydride also being formed here. Okay, all COH groups are decarboxylated while making Y. This is a wrong statement. These are not being decarboxylated. These had undergone dehydration. They have not undergone decarboxylation. So this is a wrong statement. All the carbon atoms in Y are sp2 hybridized. Perfect, beautiful it is. All the carbons, if you would see carefully, they are having one pi bond along them. All of these carbons are sp2 because there is one. If a carbon is having one pi bond around it along with 3 sigma bonds, it is sp2 hybridized. So every carbon in this case is sp2 hybridized. X is less stable than Y. This we have already proved. X is less stable than Y. I hope you have enjoyed today's session and do comment if in case you find it interesting. This will really drive me to make such more questions for you people. Bye bye. Take care. Have a nice day. Bye bye. Take care.